In our example from the last movie, we took 3 steps, the first of which was to create the class definition. In the second, we created an instance of the class, and then we called one of the attributes of the instance, the tiddles object. Now, as well as calling attributes, we can also modify those attributes in the same way. So if we decrease Tiddle's legs by 1, then we can go back to our browser, refresh. As we can see, we can use attributes in a similar way to the way we use normal variables. There are reasons not to do this, but we're not going to go into those just yet. Now, if we create 2 we create a models cat, Moggy cat to go with our Tiddles cat, and then we're going to specify here which cat we're referring to. And then we're going to go back to our browser. Tiddles has 3, Moggy has 4. Not very easy to read because I missed out the line break, but the principle should be clear. We can modify the instances of a class without affecting the class definition or any other instances of the same class. So this extends the ideas that we took on board in the chapter where we learned about functions. The reusability of the cat class is part of what gives object-oriented programming its power and cleanness. Now, we can also add a new attribute to any of our objects. So if we want to, for instance, find out what color our cats are, we can specify that Tiddles is a black cat. In fact, we can even call what kind of class Tiddles was constructed from. Let's do that. Tiddles is and then we're going to use the color that we've just given to Tiddles. And then we're going to put another space in, and then we're going to use a function called getClass. What this does is it returns the name of the class that the object, in this case Tiddles, was created from. So essentially, Tiddles is a color of the cat, we insert here, and then we insert the class name, the thing that Tiddles is and has, and then we give the number of legs. Perhaps we should specify that legs is what we're talking about. Now we're going to go back to our browser. Tiddles is a black cat and has 3 legs. Now, we might want to do the same for Moggy. But Moggy, however, will require either a complete repetition of this line or a way of automating the process of putting out this information? Well, that's exactly what we're going to do. We're going to create a simple method that will tell us about the kind of cat that we've just called. And this is how we're going to write our method. We're going to write this, and then we need to give the name of the class from which it was called. No, in fact, we'll put the color before it. Now we need to access the color attribute of the object. So we're going to use a special variable name called this. And by saying this is a way of allowing us to refer to the object itself without knowing the object name. Because when we define our class cat, we don't know what cat we're going to be creating. Essentially, we don't know whether it's Tiddles that this code is going to be used on, Moggy, or any of an infinite number of other cats that we could possibly create. So we just use the variable this, which is a special variable, doesn't literally mean variable this, to refer to the object that we call the function from. Now this function that we put within our class definition is what's called a method. Classes are made up of attributes and methods, and in this case there are two attributes that we're working with, one of which has been created inside the class definition and one of which we've added from outside, and we've only added it to Tiddles and not to Moggy, but we'll worry about that later. And we also have one method so far which we've half made, and that is our method report. And we'll see how to use this method in just a moment once we've finished creating this piece of text. So far we've got this, and then we put the color of the animal, and then we need to put the class name, which is cat. Now we could just put in cat, but let's do it this way for now. Now we need to use the this name here so that we can refer to the object, and then we're going to specify the number of legs, and we're going to put the line break in at the end that I forgot. So let's take this out because we've just replaced it with a function, and we're going to say we're going to use the method. The way we use the method is first of all we type in the object name, then we use the same little operator that we use to access an attribute, but we put the method name in this case report, followed by the two brackets that denote a function. And our report function takes no parameters, so let's just get a report on both Moggy and Tiddles for now, and we'll see what we've got there. This black cat has 3 legs, and this cat has 4 legs. Now the reason we don't have a colour for Moggy is that we never specified a colour for Moggy. So we can't put the colour of our cat into the class definition the same way we've had legs. We can reasonably assume that all the cats, when we create them with new cat, are going to have 4 legs until something happens, like to the unfortunate Tiddles, who has just lost a leg in this line of code, perhaps in a car accident, who can say. But it's not safe to assume that all of our cats that we enter into this PHP script by instantiating the cat class are going to be black cats. On the contrary, Moggy, I've just arbitrarily decided, is going to be a tabby cat. So we can't simply add the attribute to the class definition in the same way as we could with legs, because one cat can be black and one can be tabby. So although this works, and let's just pop over to our browser and check that it works. Yep, we've got a black cat with 3 legs and a tabby cat with 4. However, we don't have very efficient code. We have these 2 lines, which are essentially repetitive apart from the string that we're feeding to the attribute. The way round this problem is to use a constructor function, and we're going to take a look at that in this movie. We're going to write a constructor function. Now, a constructor function is a function that is defined in a very similar way to a method of an object. However, the difference is that a constructor function will be called every time a new instance is made of the class in which the constructor function is defined. You give the function the same name as the class. In this case, cat. And what you can do within the function is any set of attribute definitions that you want added to the cat class when it is first instantiated into a new cat object. So for instance, we could use the constructor function as a way of automatically adding a color attribute to the cat objects that are instantiated from the cat class. The way we do this is to use the this variable, which of course will refer to any cat object which is created from this class, and then we give the name of the variable, and then we give the name of the variable which we included as the argument to the constructor function. In this case, color. So this line of code will install the variable as an attribute of the new object at the point at which it is constructed by the constructor function. Now we don't need to call the constructor function separately. Because it has the same name as the class, it is automatically called in a line like this, where we instantiate a new instance of the cat class. So all we need to change here is to add the argument that the constructor function requires, as we've detailed above. So in this case, we're going to make Tiddles, let's make Tiddles grey this time, and we're going to make Moggy the black cat. Let's take out these 2 lines. I've changed the colours so that we can make sure that this new way of adding the attribute by using the constructor function is actually being carried out, so we can see that in the browser. Let's save our script, go over to the browser and refresh. As we can see, the new values have been added through the constructor function rather than having to manipulate them manually from outside. Now the reason why we couldn't simply add the attribute here, var color, is that we would need to then make all cats the same color when we constructed them. We can safely make all legs the same number, because we can assume that every cat, when we first instantiate it, we'll want to have 4 legs. But we won't want to make all our cats a uniform colour. So the constructor function is a way of allowing us to add arguments and therefore customize our objects at the moment from which they are instantiated from the class. In our next movie, we're going to have a look at inheritance and how one class can inherit from another. Inheritance in an object-oriented programming structure allows us to reuse elements of classes by creating subclasses and superclasses which inherit from each other. We can think of this like a hierarchy of different kinds of classification. To give a concrete example of the way this could work, our cat class is very broad. It includes all different kinds of cats. However, we may want to make further detailed classifications within the cat class. So we may want to separate out lions and tigers from domestic cats. We may even want to go closer than that and specify certain breeds of domestic cat. So we may end up with a Siamese class or a tiger class. And rather than having to write all of these classes from scratch, we can make all of the subclasses of cat inherit from the cat class. And this is why this is called inheritance. For instance, we may want to create a panther class. And we do this in a very same way, but in order to make the panther class inherit from the cat class, we can say class panther extends cat. And in its simplest form, the panther class works in exactly the same way as the cat. So for instance, we could specify that Moggy is going to be a panther rather than a cat. Let's save that and we'll pop over to our browser. And as we can see, the only difference that's been made is the word panther has been substituted because the report method, as we can see from our script, actually gets the class name of the object. Now, the difference between panther and cat at the moment is pretty much none at all. We can see that by using the extends command, panther has inherited all of cat's characteristics wholesale. So panther is in effect at the moment the same as cat. How we make differences between panther and cat is that we can specify within the class definition of panther certain variations. So, for instance, we may want to point out that all panthers are black. So, we're not going to allow the color of panther to be defined by the user or by later on in the script. However, we also need to disallow this constructor function. Now, although this constructor function is known as the cat constructor, because panther has inherited from cat, it has inherited the constructor function, which is in effect a panther constructor function. So what we need to do to overwrite that cat function is to say function panther nothing at all. And what that does effectively is to replace the constructor function that we inherited from the cat class with an empty constructor function, so that no argument is required when we create a new panther. We'll save that, and if we go over to our browser, clicking the refresh button, we'll see nothing changes at all, but the panther has stayed black. And what that means is that our panther has taken its color from the class definition itself, rather than from any argument. So if we wanted to make a white panther, we could try that, but we'd go over here, refresh, and the panther would stay black, because our constructor function that we added in the cat class has been overwritten by this blank panther function. Now, we may wish to take our class back a stage further. So if we wanted to create a snake class, and this is not going to inherit from cat, but we want certain things to be similar. We want to have a snake function that will let us define, this is going to be the constructor function, that will let us define the color of the snake object that we're going to instantiate from the snake class. However, we want the legs to always be 0. And then if we want to be able to report about our snake, then we're going to have to add this function report. Now, something must be going wrong because we've got duplication here. We've got an identical constructor function apart from the name, and we're just going to have to add this report function as well. Now, whenever that starts happening, that's warning bells should go off, and we should take a step back and say we should be able to find a more efficient way of doing this. So a way to do this would be to create a superclass for both cat and snake, and we're going to call this the animal class. And we're going to take out the constructor function from cat. We'll take it out completely and add a constructor function to animal that does exactly the same thing. And then we're going to make the cat class inherit from animal by saying extends animal. Then we're going to put the report function into the animal class as well. And now our cat class has been substantially reduced in size, and all our snake class has to do is to extend, we have to say class snake extends animal. So we can take out the constructor, and all we need to specify are the things that are unique to the cat class and the snake class. Now, if we wanted to get really technical about this, we'd create a mammal class, and we'll get into all kinds of complex biological gradations of classification of species. Of course, we're not going to do that, but the point I'm trying to get across is that object-oriented structures such as this allow for complex relationships between different kinds of classes and allow the programmer to save resources by avoiding all kind of redundant script. Let's create a new creature. We're going to call this one, we can take that redundant white there as well, and we're going to create Hissy, and Hissy is going to be a new snake. And we better give our snake a color, so that's going to be a brown snake, and we're going to say Hissy report. Now, because snake inherits from animal, the report method, which we've installed in animal, is available to snake. It's also available to cat, and because panther inherits from cat, the report function is available to panther. Now, as we can see, panther's constructor function overrides the constructor function that was passed from here to cat and to panther. So the rule of thumb is that PHP will look at the smallest class, the end of the tree, and then if it doesn't find anything there, it will work its way back up to the root class, in this case, the animal class. Let's save that, and we'll take a look at our browser. And here we have the brown snake making use of the functions that we've added to our animal class. Now I should hope that some of the power of object-oriented structures is coming through in these examples. Although they don't do anything useful by themselves, they exemplify the kind of flexibility that programming using object-oriented structures allows. And in our next movie, we're going to take a brief look at the concept of polymorphism. The idea of polymorphism is that when we look at an object and ask it to do something by calling one of its methods, we don't really need to know how it does it, or exactly what it's doing in its internal workings. We need to know how it works when we're writing the class and defining the methods, but we don't need to know, as programmers making use of the object, exactly how this happens. For instance, we could have two separate objects created from different classes with methods that have the same name, which will do similar things, but with a difference depending on the kind of object that we call the method from. However, the principle of polymorphism is that we don't need to specify anything different when we ask that object to do whatever it is we want to do. Let's look at a concrete example. If we add a method here to the cat class, and we're going to call it make noise, and all this function will do is to make a cat noise. Now, let's say we go back here and strip away some of this extraneous data, and we're going to take out these three reports, and all we're going to do is we're going to ask Tiddles to make noise by calling the make noise method, and then we're going to ask Moggy, the panther, also to make a noise. Let's save that, and we'll have a look at what happens when we refresh our browser. Now, both Tiddles, the cat, and Moggy, the panther, have made a noise. Unfortunately, because panther inherits from cat, the make noise function has been inherited exactly the same way. So our panther, our big, supposedly scary panther, is making a meow noise. So what we want to do is to overwrite that with a function that makes a more panther-like noise. Now, I'm assuming that panther's raw. I don't have any special knowledge of that kind of thing, so if I'm biologically inaccurate, I hope you'll forgive me. Now let's see what happens when we refresh. As we can see, our panther method, make noise, although we called it with exactly the same syntax, we asked Tiddles to make some noise and we asked Moggy to make some noise, the panther roared while the cat meowed. The reason why this is an important concept in object-oriented programming is that it allows the object to take control of the way it works, so that we can ask two different objects, the same request, and based on the different workings of the two objects, we can end up with two results. This makes for cleaner, more encapsulated, and more intuitive ways of coding. In our final movie in this chapter, we're going to have a look at inheritance and aggregation are two very different but very important principles of any object-oriented structure. The difference between inheritance and aggregation is best understood through looking with a little common sense at real-life examples. Aggregation is a way of grouping together objects that are not in their nature similar necessarily, but should be grouped together for some entirely separate reason. For instance, a pet shop can contain a lot of animals, but the animals would not inherit from the pet shop because the animals are not a kind of pet shop, whereas panthers are a kind of cat, and cats are a kind of animal, so that structure uses inheritance. Let's have a look at the way aggregation of objects can work. We're going to take out these instantiating commands down here, and we're going to create a new class, and this class will be called Pet Shop, and it's not going to inherit from any of the other classes we've defined at the moment. Now we're going to set up some attributes within the Pet Shop class, and the first of which is going to be an array which is going to contain all the pets that we add to the Pet Shop, that we add to instances of the Pet Shop class, I should say. Then we're going to need a cache variable, which is going to store the amount of cache that the Pet Shop holds at any one time. We're going to make an addPet function. Now this addPet function is actually going to create new instances of the animal that we want to add to our Pet Shop stock. We're going to specify the class that we're going to call them from, the price, and the color. So we're going to set up a little variable called nPets, and what that's going to do is it's going to count the number of pets that are contained within the Pet Shop object array pets. So that's going to see how many pets are already in the Pet Shop. At the moment, 0, or from the moment that the Pet Shop is instantiated, it will be 0. And then we want to add a new pet to the pets array. In this case, it will be 0. So the pets array, element 0, which is the first element, that will be the first time this function is called. The next time it'll be 1 and 2 and so on. Then we say new pet class. Now, as we can see, we can create a new instance of an object without even knowing the name of the kind of animal that we want to create. So this will allow us to automate the process of creating the animals. Then we're going to add a price to the animal itself, and we're going to store that price on the animal. So our animal, whatever it ends up being called, will have a new attribute thanks to this function, which is going to be its price tag, maybe hanging around its neck. Then we're going to make a sellPet function, and all we're going to need for this is the pet number. because our pets are going to be stored numerically in an array. The pet shop, of course, will not name the pets. That'll be up to the owners. So our pets are simply known by the number, say the number of the part of the shop that they're sitting in. In the case of our pet shop class, it's going to be the number of the element of the array. Then we're going to have our sell pet function. And what that's going to do is it's going to add to the cache variable the price of the pet. And we're going to have to specify which pet we want, so we're going to use all the way through, as you can see, we're using these operators to specify the attributes of these objects. Then we have to remove from the pets array the element that we've just sold, the pet that we've just sold to the customer. So we're going to use the array splice function, and what this does is it takes as its arguments the array, in this case this pets, and then the element that we want removed, and then the number of elements that we want removed altogether, in this case only one. Then we'll perhaps add a little notice to say that a particular pet has been sold, then we're going to type in the cache. You'll notice that I escaped the $sign, otherwise PHP is going to assume that by putting in a $sign I am trying to define a variable. Then we're going to put a couple of line breaks after that. So we've added facilities to add and sell pets to our pet shop class. Now let's finally have a class that is going to show the stock of pets that are in stock at the moment. And so we're simply just going to put in something to say, in bold it's going to say shop stock, and then a line break we have, and then we're going to count the number of pets. So we're going to count the pets array, which will contain all the pet objects that we've created. Then a couple of line breaks, and then we're going to iterate through the pets and we're going to specify each of the pets that are stored in the pets array, and we're going to say pet number I and then we're going to add the report for the pet. Which we can use by calling the particular element from the pets array, and then we're going to call the report method that we created in the class definition for animal. So each of the pets is going to include that. Then we're going to put at the bottom the price, and we're going to escape the $sign again using the backslash, and then we're going to say we're going to write down the pet's price once again. And then finally another line break. After that we're going to pop in another line break for the sake of neatness, and then that is going to be our pet shop class. That may look a little complicated, but really all it is adding to the array, the pets array, and creating an object, removing an object from the array, and reporting on the stock of the pet shop. Now, let's call our pet shop shop. Not a very imaginative name, but there we go, new pet shop. And we're going to say shop, make a bit of space there. We're going to say shop, add pet. And now we just type in, as we can see, the add pet took 3 arguments, and that was the name of the class, pet price, and the pet color. So we're going to say, we're going to have a cat, and that's going to be $20, and it's going to be a tabby cat. Then we're going to add pet. Now this one's going to be a snake, 40, and that's going to be a brown snake there. We're also going to add let's have 2 snakes, in fact. Let's have a more expensive snake. Let's have a more expensive black snake. And then we're going to try out our show pets function. Let's sell one of our pets after we've shown the pets. Let's sell the first pet, which is the tabby cat. Then we're going to show the stock again. Now that's a lot of typing without testing. Not something that I recommend you do. Of course I've tested this script before, which is why I'm doing it. But it's much better practice to test out each little tiny bit of the code as you're typing it. Then if there's any errors, you can see exactly why. Let's pop over to our browser though and take a look at the way our pet shop is working. As we can see, our first function, the show pets function, shows that we have 3 pets for sale in the shop. The cat was sold, and then there are only the 2 snakes left as the stock in the pet shop. This is an example of aggregation. The pet shop contains a number of objects within itself that are not related to it by inheritance, and it manipulates those objects by calling its own methods and using them on those objects, and it also calls the methods of those objects themselves. Once again, this is quite a lot to digest in this chapter, so I really recommend that if you're going to use any of these methods, that you try all the examples out for yourself, take a look at the source code included with this chapter, and try to make your own examples of an object-oriented structure of your choice. In our next chapter, we're going to create a sample PHP app.